unattended, your value as an operator or a programmer goes that much higher up.
Hello, we're at Fuji, America today, not in Japan, but here in the US, a gantry loading system zipping through its processes. We know the speeds of a gantry load, we know the importance of automation, but this isn't about me. My camera person can point right over here to my friend Eric. We're talking Fuji America, Eric, we're talking gantry loading, we're talking speed. We got a couple of great technologies today to go over. Would you mind describing a little bit about this machine and what the audience might be looking at?
All right, well, the CSD 302, that's our front-loaded dual spindle machine. It's loading it with a dual spindle gantry. And then also we have a two-place flip over station on the inside of the machine. We're able to run from a front loader, two op 10 and op 20, able to flip it in process, loading from a work stocker here, and then offloading into a work stocker on that side. So in an unintended environment, you just run in the first spindle on the op 20 and then come back to finished parts over here.
You know, I'm looking at this, Eric, and we're grateful enough and honored enough to do a lot of interviews, right? So we get to discuss technology all the time.
Right.
And I'm looking at this and I'm going, wow, okay, how many times have I seen a machine do op 10, then you gotta manually flip the part over and do op 20, or maybe we have op 10 and op 20 inside the one machine, but we don't have the gantry loading and unloading to add the automation. I mean, to me, what I'm trying to get to, coming full circle to what you were just describing, is that we are now doing something that needs to be done in an automated fashion faster. And I like that a lot.
Right. And also we're adding more versatility because everything's built into the machine. There's no integration involved. We don't have to have outside entities come in and change things. Everything's included. So if we need to run 4 parts of one piece and then 100 parts of another piece, it's all right in on the control and can be really easily managed from that point.
I like that. I like the word versatility. I like that you said that. Flexibility pops up for me as well because you mentioned, in considering the numbers, a high mix, low volume, and a low volume, high mix, two different options that you can do in this setup. And something you started with that I like a lot as well, Eric, is the communication. Sometimes we'll bring in partners, and a lot of the partners are great. Let's be honest, folks, there's a lot of great partners out there. But occasionally you'll walk into a shop and go, what, the two aren't communicating? Don't worry, I have a solution. Everything communicates together, right?
Correct. Yeah, and that's it really, the most important part is to alleviate downtime. So from setup to operation, unattended machining, and then also, God forbid, there's, problems, it's easy to get it fixed. And that's, avoid downtime, up chip time, and unattended time.
Yeah, so we're gonna walk this general direction, look at the other technology, but as we do that, Eric, the first thing that popped into my head when you said, we're gonna help you with the problems, I think I'm old school. Vanilla Ice popped up and said, if there's a problem, yo, I'll solve it, check out, gosh, sorry guys, I had to do it. But we don't want problems, and you mentioned being able to do more. You mentioned the versatility, the flexibility. We didn't actually say one of the buzzwords that's out there right now, but we all talk about it, maybe more, I don't know if it's more than we should, but we talk about it, and that's the labor shortage. And if we can walk away from a machine and allow these machines to do some work, then we're kind of doing what we can. Of course, we're creating more education and awareness, and even making manufacturing fun, or at least we're trying to, but these machines help with that as well, don't they?
Yeah, it gives an opportunity to, for a long time, people weren't coming into the trade because they didn't want to learn how to, run a manual mill or a drill press or sharpen a drill or, do all the crappy stuff that comes with it. They want to come in, start pressing buttons, the video game age. They just, $500,000 piece of equipment, they just want to start pushing buttons. And, we try and get them excited. We try and start them at the beginning. We walk them through. But to be able to, run multiple parts and run multiple programs, unattended, your value as an operator or a programmer goes that much higher up.
Yeah, you're right.
Same thing for the shop owner. He's going to sell that same thing to get his product produced.
Yeah, you're exactly right. Yeah. And I'm going to segue you into this machine in just a minute, but I want to bring up some valuable points you just said. I'd like to talk to the audience a little bit about that. You're right, everyone wants to jump onto a machine in a $500,000, $1 million machine. Oftentimes that's how machines break. Because I come from, and somebody for sure is going to call me out and be like, I was back with the tape and you're on the floppy disk, but I started on floppy disk, right? So I was in that age of feeling the vibration of the manual machines, the hum,
Sure.
the purr, the chips that would come off of it, and we've kind of lost a bit of that. Everyone wants to get into CAD and designing and work with the robots. So I'm just going to bring that full circle as we get back into the machining world. So what's this machine up to?
All right, so this machine is also automated and starting from a work loading station. But this is an opposing horizontal spindle machine.
Oh, nice.
So we have a left side, we have a right side, and then we have the robot, the arm comes from left to right, crossing over the middle section. It's a double gripper robot, so it's able to take the first op 10 finished, take the finished complete part from op 20, put the op 10 in it, and then it brings the finished part to the workstation, grabs a new part, and it's ready to load into op 10. And again, that unattended continual machining.
In the assumption, and we're both wise, we kind of know what assuming can do.
Sure.
I won't go into the details of how that
right.
word spins out, but assuming that a job is op 10 and op 20, we're looking at a done in one type part. We're looking at really just trying to take it from a raw material, machine one side, machine the next side, and then finish it off.
Sure.
I would imagine, maybe I'm assuming again, there's probably some form of a measurement system you could add to this if you wanted to even take a look at that. Is that correct?
Right, and it also has the capability to stop within production, allowing you to take a part out, inspect it through inspection, get through a first article. Yep, this part's great, continue, and then hit start.
So to me, and this is why I bring the experts, so correct me if I'm wrong, and I do say that a lot because I love being wrong and I love learning. But correct me if I'm wrong, from the machine we looked at over here to the machine we're looking at now, it really feels like it's about speed and flexibility and doing more within one unit, and we're just kind of taking one of the axes and flipping it, and then just kind of doing something similar, right?
Absolutely. And over here, the difference is going to be you have a center to chuck environment on the left and the right side. So it could be where you run the part, it's going to be a low diameter and a longer length. Where in that application over on the gantry, it's a more shallow part with a larger diameter.
Clever.
So in every aspect, from chip management to tool management, inspection, maintenance, again, the chip management is a big part of it. Mm-hmm. We don't have anything interfering with that application.
I'm going to ask you one more question, if it's all right, Eric. And I kind of want to just take a quick glance at this software here. And it's only because it seems so user-friendly. When I look at my iPhone, or we look at a smartphone in general, this seems to almost not mimic it, but it's very colorful, and the screen seems friendly. It seems like a user would want to be a part of it instead of shying away from it, going, that looks like a whole bunch of numbers, a bunch of zeros and ones over there, binary coding.
Okay. Well, on this system here, you'll see we have two interfaces. One is the Fuji interface, and this is going to help you set up the left and the right spindle to spindle, what program it's going to run, speeds and feeds, different live tools. Over here, then you go to the robot, and that's going to give you your start point, your teach points, and where the robot is going to move and change parts. And then on peripheral devices, if you're going to add inspection, if you're going to add, pre-inspection or something along that line, that would be done there. Now here is what most operators are used to seeing this. It's a FANUC interface on the front end of the controller.
Sure. So we've covered the machines, we've covered the technology. Much like being able to teach here, you've taught me a lot as well. Are there any final messages you'd like to offer the audience about Fuji America, service support-wise, how they can find you and learn more about the technology?
Oh, well, we do have a fantastic website at fujimachine.com that has a virtual tour that goes through control, each machine, different applications. We work through distribution network through each region of the country. I work particularly with Selway Machine Tool throughout the whole West. Service, applications, our distributors are trained, and we also, bring guys out from the Midwest, depending on what state. Really just come step up to automation.
There you go. Step up to automation. Great closing statement. Also a nice little shout out to our friends at Selway. Zach, Preston, you guys over there, we do enjoy you. Eric, appreciate you so much, my friend.
Thank you, sir.
Always love learning about new technology, and I have spent time at the Fuji Mountain in Japan. Have you?
No, I have
Fuji?
Not yet.
The trip is coming. We put it onto a documented platform. Now we got to go.
All right.